Okay, I've gotten some emails that people are still having trouble with some of these proofs. So what I'm going to do is I'm going to prove two different ones, and hopefully you can follow these and these help. Any other questions, please email me or ask me tomorrow. Now, looking at this proof, the given information that line segment JK is parallel to line segment LM. Now, again, when you see that parallel lines, it should be kicking in what we reviewed today, an angle congruence, and possible reasons for the angle congruence are corresponding angles, alternate interior angles theorem, and alternate exterior angles theorem. Now, again, those all depend on the lines being parallel, and because they are, that's really what you should be looking for. What it says is we have two different pairs of parallel lines, which is good. We can go ahead and mark those. We have JK parallel to line segment LM, and we have line segment KL parallel to line segment JM. That's not congruent, it just means parallel. And what we're trying to prove is that triangle JKL is congruent to triangle LMJ. Now, as far as triangle congruency goes, we talked about today, our possible options for triangle congruency are side, 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 angle, angle, side, angle, and angle, angle, side. Now, normally we wouldn't write these reasons down here. We would only write the one that we use in the end, but again, this will help hopefully steer you in the right direction. Now, again, where to start? Well, once you see parallel lines, okay, you have to know your reasons well enough to know that parallel lines lead to corresponding angles being congruent, alternate interior angles being congruent, and alternate exterior angles being congruent. So those are angle congruent statements. And looking here, if line segment JK is congruent to line segment LM, we're dealing with this transversal. We could put angle 1 here and angle 2 here. Now, angle 1 is angle KJL, and angle 2 is angle MLJ. If you look at these are alternate interior angles on parallel lines. For example, angle 1, one of the sides is line JK, which is parallel to line LM using this transversal. Okay, parallel line, transversal, other parallel line, and transversal. These alternate interior angles on parallel lines have to be congruent. So angle 1 is congruent to angle 2 by the alternate interior angles theorem. Okay. For the exact same reason, angles 3 and 4 would also be congruent. Now, they are on a different pair of lines, but both pairs of lines were given to be parallel, so we can use the same reason. So angle 3 is congruent to angle 4 by the alternate interior angles theorem. Now, what I'm going to do is I'm going to mark these accordingly. Okay, one arc here, two arcs here. Alright, so now what we have is we have an angle congruent statement and an angle congruent statement. What that allows us to do is cross out the possibility of side, 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 and also side, angle, side. If we have two angle congruent statements, it's either going to be angle, side, angle, or angle, angle, side. Now, in order for this to be angle, side, angle, this side has to be included between the two congruent angle pairs. And if you look in the top triangle JKL, angle 1, angle 4, the side included would be side JL. For angle 2 and angle 3 in triangle LMJ, that included side is also JL. It's the same side. And if you look down here at what we're trying to prove, these triangles J, L, L, J, corresponding order, we know that these segments have to be congruent by the reflexive property. Remember, the reflexive property states that a segment or angle is equal to itself. Now, I've already marked it in the diagram. Now that I've listed it here, I have a segment congruent statement. Now remember, the order in which we list these statements here is not what determines our reason for the triangle congruence. It's the order in the diagram. If you go in triangle JKL, angle, side, angle. In angle LMJ, we have angle, side, angle. Again, we don't start here at angle 1 and loop all the way around to angle 4, because we would be skipping this side, this angle, and this side. We're only allowed to skip one consecutive adjacent part at a time. So in this case, the order in the diagram is the congruent pieces are found. It's angle, side angle. So we prove these triangles congruent by the angle, side angle theorem, and that's how you complete this particular proof.